Am I audible? Can somebody confirm? कपड़ा अंदर खाली बोलना का पड़ेगा. Hello. Can somebody confirm that I am audible? Please confirm.
Yes, sir. Audible.
Yeah. Is my screen visible? Is my screen visible?
Yes,
Whatever
sir.
I am presenting is visible?
Yes, sir. Visible.
Please confirm.
Yes, sir.
Hello.
Visible.
Can I confirm?
Yes, sir.
Okay. Okay. So it is confirmed that I'm audible and my screen is visible. So as you know, we have completed our syllabus, and today onwards we are going to have a brief revision of whatever we have learned throughout the semester. So almost we have taken 80 lectures in this particular 80 hours lectures in the semester till date, and still that means to complete the syllabus. And from today we will concentrate on brief revision of what we have learned. So let us see the syllabus first and then we will proceed. So this is your chapter number 1, where it is clearly mentioned. The name of this particular chapter is Introduction to IC Engine. The points to be covered in this particular chapter were introduction, classification of IC engines, engine cycles, auto and diesel cycle, wall timing diagram for high speed and low speed engines, and port timing diagram for two-stroke and four-stroke engines. Port timing diagram for two-stroke engines, and yeah. So that much is the points that are supposed to be covered in this particular chapter. So basically, to cover this many chapters, let us move ahead. So our chapter number 1, we started with the constructional details of IC engine point, and we discussed something about should we study IC engine or not. That was the first point what we discussed, because nowadays there's a lot of discussion about electrical vehicles, and this is one of the statistics what I have related to electric vehicle and uh, ICE engine vehicles. So the the blue bars indicate the ICE engine vehicles, and the red bars indicate the red and the orange bars indicate the uh, battery operated electrical vehicles and hybrid electrical vehicles. So very clearly it is seen that, see, presently we are in 2020, where we have around uh, these many ICE engine vehicles, so a lot of ICE engine vehicles and very few electrical vehicles. Though the electrical vehicles are going to increase in the next 20 years, you can see the along with that, ICE engine vehicles are also going to increase for next 10 years, and thereafter uh, there will be more increment in the electrical vehicles than ICE engine, and 100% replacement of the ICE engine vehicles are not going to happen in near future, because our technology is not that developed, and take into considerations the technology development time requirement, and the transition from one technology to another technology will take a certain amount of time, and people also has to be get convinced to the use of the electrical vehicle. So there are pros and cons for each, and customer has to take decision in such cases which has to be used. And obviously electrical vehicles cannot be run in a stretch for long distance for long hours, the way we do for IC engine vehicles. So that becomes a biggest disadvantage. So frequent charging and so, like that, so many advantages and disadvantages are there for each technology. And due to that, you can see ICE engine vehicles are not going to be replaced in a near future completely. So that is what the meaning coming out of this particular slide. So because why I have put this particular slide at the start itself, because there is a misconception that now onwards we are going to have electrical vehicles, and then why to study IC engine subject as such. And not only that, IC engine is going to be applicable only in automobiles. It is used in aeroplanes, it is used in helicopters or in aircrafts and marine applications like ships, boats, etc. Then generation applications like diesel power sets, agricultural applications. So there are so many applications of IC engines, and one of the application is automobile, and that too is not going to replace in the near future. So taking this into consideration, being one of the important subject of mechanical engineering, there should not be any misconception in your mind that why to learn IC engine subject. Okay, so this is what we try to focus on: distinguish different types of engine constructions, differentiate the constructional details of various fuel systems used in. So this is the objective of the IC engine subject as a whole. Differentiate the constructional details of various fuel systems used in IC engines, and calculation related to their major dimensions. Then apply the basic knowledge to infer the different methods for enhancing the performance, like supercharging, turbocharging, etc. Correlate different SI and CI engine combustion process. So how the combustion happens in SI and CI. Evaluate the performance parameters. So whatever the different performance parameters like BP, IP, etc. Brake thermal efficiency, indicator thermal efficiency, etc. How to calculate them, how to find out the performance of an engine, that, and then something related to fuel and pollution we should also learn. So these were the outcomes. So we have discussed all these particular outcomes earlier too. So these are the 8 topics. So we are now today focusing on introduction to IC engines, first chapter. Then these are the books. So I have told you to go to library and get your book uh, issued from the library so that you can start your studies. I hope you have done that. Now let us move on to chapter number 1. So uh, once again, am I audible? Am I audible?
Yes, sir, audible.
Okay. Because this was I asking because I am not able to confirm due to the internet problem. Only one internet with the mobile. I'm connecting with the laptop, and then simultaneously I cannot confirm. Okay, so any discontinuity in the network, please inform me through WhatsApp so that I can check my WhatsApp and confirm that I'm audible or not. So introduction, classification of IC engine, Otto cycle and diesel cycle, wall timing diagram, and code timing diagram. These are the points. So this is a heat engine. So basically, a heat engine is a device used for converting one form of energy. Engine is a device used to convert one form of energy to another form. Okay, and this is what how it is shown thermodynamically. This we have discussed in detail. So we have a high temperature source, low temperature source in the engine working between these two temperatures, and we have a work output. So W is equal to QH minus QC. That was the equation what we have um, uh, we have learned in thermodynamics. Okay, so all these things we know. Then we coming to heat engine. Heat engine is a device used for conversion of heat to thermal energy into mechanical energy. Okay, so we have heat over here, and that is being converted into some mechanical work. So this is what you have heat engines. Heat engines are of two types, external and internal. If the combustion is happening inside the area where the energy conversion is taking place, that is called as internal combustion engine. If the energy conversion is happening outside that particular area, then it is called as external combustion engine. So this we have discussed. So these are the different parts of a different IC engines. So um, you can see over the list of the parts: crankshaft, cylinder head, flywheel, cylinder block, carburetor, piston, exhaust valve, timing belt, connecting rod, timing belt, cover, then fuel injector, oil pump, catalytic converter, oil seal, turbocharger, fuel tank. So a list is given. Coming to the first, cylinder block. So this is a basic construction. This is a basic part of an engine on which all the other parts are being connected. Okay, so this becomes the basic part of an engine, that is cylinder block. Here there are water jackets, then the cooling system is attached, everything is attached on this, generally manufactured of cast iron or low carbon steel. Casting or forging depends on process of manufacturing depends on how bigger it is, what is the ease of calculation, what is the complexity in the part, etc. Engine cylinder. uh, so aluminum, silicon, etc. can be used. Cylinders are there. So the main function of the cylinder is to guide the piston. So we can see over here in cylinders in a rotary engine and cylinders in a V8 engine. So these are the cylinders, 1, 2, 3, 4 cylinders. Here these are the cylinders. Okay. So here this is a Wankel engine. We have discussed how it is working. So this is a constructional detail of a IC engine, a single cylinder engine shown in the figure. So here is your cylinder, this is your piston, this is your cylinder block, and so on. So okay, so this is cylinder head, which forms the upper cover. which closes the cylinder and provides the area for combustion chamber, in which walls are connected. So one big wall is the inlet wall, one smaller wall is a exhaust wall. So you can see every cylinder. So this is a cylinder head for four-stroke for four-cylinder engine, and every cylinder has two walls. It is generally made of casting, and aluminum alloys are preferred because the higher thermal conductivity of aluminum is required to remove the heat, which is being transferred continuously to the cylinder head. So that is about the cylinder head. So this is how the cylinder head of a single cylinder diesel engine look like. Okay, so here you can see the two holes for inlet and exhaust, through which air is going to come in and the exhaust gases are going to go out. And on the upper side you can see the wall operating mechanism, with the rocker arm and etc. So how it is functioning and all we have discussed in detail. So here this is the same figure with the rocker arms. You can see over here, on one side you have one wall, the other side you have other wall. Okay, and it is operated over here. um, this will be operated in a manner where to when to open the wall and when to close the wall and all such things. uh, this is a manifold in. So this is your intake manifold where you can see the spark plugs connected. So this through this holes, at this particular holes we are putting the walls, and when these walls are open, inlet airs or mixture whatever is going to be there, that will be coming into the combustion chamber. So similarly we have exhaust manifold also. So this is how the exhaust manifold look like. Here this sensor which senses the temperature of the exhaust gases, or it may be oxygen sensor which senses the amount of oxygen being coming out of the exhaust gases. And this is a arrangement for cooling water, where the cooling water is going to be circulated. This is a cylinder liner which is put inside the cylinder of an engine, because we want different properties required for the cylinder wall. So that is being met by using a cylinder liner. These are the piston pins which are connected at the small end of the connecting rod. It is also called as gudgeon pin. It is generally made of plain carbon steel. So here we connect the small gudgeon pin or the piston pin, and this is your piston. So see, whenever somebody joins, I have to okay. So this is a piston pin function. It transmits the forces and serves as a guide for the bearing, forms the seal for high pressure gases. Aluminum is generally preferred. If aluminum is used, it is lighter, higher thermal conductivity, but obviously it's not as strong as cast iron. So these are the different constructional details of different types of pistons which can be used in the different applications. Where you can see these are the different piston rings. We have a compression ring and we have oil control rings. So the compression rings are there to prevent the leakage of the gases, compression gases, and in order to ensure the lubrication of the cylinder wall, we have this oil control rings. Set of compression ring and oil control ring will be there. So cast iron material will be generally preferred. Spring material, spring will be generally preferred because the springiness is required. And so piston rings prevent the leakage of the gases, prevent lubrication of the oil film, and prevent the lubrication entry of the into the combustion chamber. So it has to oil should be prevented from coming into the combustion chamber. So it function is to scrap it away, remove unnecessary excessive lubricating oil, prevent the carbon deposit, easy transmission of heat, and balancing of the side thrust of the piston. So these are the functions. So this is how a piston and a connecting rod is connected with the help of a gudgeon pin, and this is the connecting rod, how it looks like. So this is a small end, this is a big end. So you can see over here, this can be divided into two parts, and we can have these particular screws to connect, nuts and bolts to connect it. So this can be removed. Inside this, a bearing will be put. Um, it can be a bush or it can be a bearing, depending on the applications. So here it will be put, and inside this will come your connecting rod, and you have this particular screws tightened, or the nut bolts tightened, and this will become the big end of the connecting rod. So the connecting rod is generally forged. Uh, um, it can be of aluminum also sometimes, or steel, but preferably malleable, or graphite. Spheroidal graphite cast iron is preferred for connecting rods. So these are the different designs of the connecting rods which can be used in the different applications of IC engine. Here, this is a slide where you can see the lower part of the engine, how it is being arranged. So this is your connecting rod. This was now what I was explaining. We have the bushes over here. So one bush will go here, the other bush will go here, and then it will be connected like that. So this becomes the lower part. Upper part will become your the connecting other part of the connecting rod will be connected over here, and this particular nuts when tightened, you are going to have this particular arrangement where this crankshaft can rotate. And here we have this particular gears where the power can be transmitted from this shaft to this camshaft and other parts. Okay, so the connecting rod and the piston assembly is coming over here, and it will be connected over here, and the lower part it is here. So the engine bearings, so this is how the engine bearings, so this is the bush bearing whatever you are having, and it is put inside this, and this becomes the lower part, this becomes the upper part, and then it is connected. This is a complete assembly of the crankshaft, connecting rod, piston arrangement with the flywheel. Okay, so you can see over here how it is connected, and here when it is rotated, the piston is going to move up and down inside the cylinder. So this is a very big connecting rod used in a marine application. So you can see the size of the connecting rod. You can imagine that by understanding the size of a person over here. So this is the size of a person, and this is the size of the engine. So sorry, the cam lobes of the connecting rod. The offset of the connecting rod. Okay, so this is where you can see how much bigger size it is. And we have a provision for lubrication where the oil is going to circulate and oil is going to transport to different parts. Then the crankshaft can be forged preferably, but it can be casted also. Forging steel or spheroidal graphite or nickel alloys can be also used depending on the application. Then we have the connecting rods. Connecting rods are generally alloys. Method preferred is casting. So the connecting rod, you can see over here the holes. These holes are meant for the lubrication. So this is the point where the big end of the connecting rod is connected, and this is the point where there are supports. Okay, so the bearing supports are here, and this is the point where these are the points 1, 2, 3. So these are the points where these are the points where you are going to connect the big end of the connecting rod, different connecting rods. So it is something like this. Different types of connecting rods are shown over here with the assembly. So of a connecting rod and the piston arrangement along with the connecting rod, crankshaft. So here the valve operating mechanism. So you can see the camshaft over here, and when the camshaft lobe is pushing this particular push rod, the rocker arm will be moving up over here, and on the contrary it will be going down over here, and when it is pushed down, the valve is going to open and the gases are flow across the valve seat. So this area is called as valve seat. So across this particular area, the gases are going to flow. If it is an inlet valve, gases will be flowing in, that is air is going to flow in or mixture is going to flow in, and if it is exhaust valve, then the gases are going to flow out. So This is a wall operating mechanism. So these are the different walls, how the constructional details of the walls we have discussed in detail. Uh, so this is a push rod and connecting rod assembly shown. So this is a wall from the the camshaft lobe, uh, uh, cam lobe, and when the cam lobe pushes this, this is the follower. The follower is going to push, or the push rod. So the follower is this, and when it is pushing this up, this end of this fulcrum, which we call as a rocker. This is going to move up. When this moves up, this moves down, and when this moves down, this pushes the wall down, thereby opening or closing. So it is here. It is how it is shown very clearly. When this moves up, when this moves up, this is the fulcrum over here. When this moves up here, this moves down over here, and that will result in the pushing of this particular walls down. So this is how it is connected, and here it is shown uh, the connection of the uh, crankshaft and the camshaft. So here the two camshafts are shown. Preferably it is a overhead double camshaft type of arrangement, where two camshafts are there, one for the inlet wall and one for the exhaust wall. Okay. So here it is this is an engine where we have 4 walls per cylinder. So 2 inlet walls or 2 exhaust walls will be there, and accordingly this is how it is connected. So these are the camshafts. Single overhead camshaft arrangement is shown. The presently whatever we have seen is a double overhead arrangement. This is a single overhead arrangement. This is a double overhead arrangement, the overhead camshaft arrangement. So this earlier one was a single overhead camshaft arrangement. Then this is the double overhead camshaft arrangement. This is your crankcase. So the crankcase is the lower part where the lubricating oil is put inside it, and it becomes the source for lubrication oil as per requirement. So whenever we are going to put the oil, we will open the provision made for the cap to open, and we will put the oil inside. And frequently we will ensure that the oil level is as per required, and the quality is also as per required. If quality is being deteriorated, then we have to replace the oil, or if we check the oil level, if the oil level is decreasing, then also we have to refill it. So it is there in the oil sump of the crankcase. This is a flywheel, so that is a balancing weight to go for the storage of the energy as per requirement. So all the cylinders are not getting the power simultaneously, and sometimes power stroke will be in one cylinder, the other will be in a different stroke out of the 4 strokes of the engine, and that has to be continuously ensured that the crankshaft is going to rotate with a uniform rotational speed, and that is being done with the help of a flywheel. So a flywheel is a rotating mass used to energy storing. A flywheel is secured on the crankshaft. The main function of the flywheel is to rotate the shaft during the preparatory stroke. It makes the crankshaft rotation with a uniform angular velocity. Material is generally used is cast iron, and method of manufacturing is casting. So this is the sump which is connected at the crankcase with the oil pump in it. So you can see over this is the sump part, and this is the oil pump which is connected. So this is a filter. So the filtered oil will be pumped onto the oil galleries. This is a radiator used for the cooling of the cooling engine, the cooling system of a engine. Okay, so the radiator is basically a heat exchanger which transfers the heat from the cooling water to the atmosphere. So these are the spark plugs used. So there are different types of spark plugs. Okay, long reach, short reach, and so many types of spark plugs are there. Different for different types of engine, different types of combustion chambers. We have to use different types of spark plugs. So different types are shown here. Its main function is to provide the spark. So it has a central electrode and one earth electrode. So this is the earth electrode, and this is the central electrode. The spark is going to happen between this. So when we give the voltage, we'll be giving to the central electrode, and this is earthed, and therefore what happens is whenever we supply the voltage, here there will be a spark. and that spark will be resulting in the burning of the mixture. This is in case of SI engine. So that is about the spark plugs. Then we have the governors. Governors are there to regulate the speed of the engine. So whenever the load on the engine changes, then we have to ensure that this governor will come into action, and it will ensure that it will cope up with the load requirement by changing the fuel supply. Okay, so all these things and the different types of governors also we have discussed. Then we have the carburetor. So this also part we have discussed in detail in the second chapter. So this is a device used for preparing the mixture and supplying to the engine as per requirement. Okay. Then the fuel injectors. So this preferably used in diesel engines where we have to inject the fuel. So how it is working and all we have discussed in the chapter number 3. This is a turbocharger, which is a supercharger basically. So it is a compressor run by some arrangement. So turbocharger, as you can see, the exhaust gases are coming in. This will rotate this particular turbine, and on the same turbine shaft, we are located the compressor also. So the compressor will rotate. It will take the air from the center, and it will supply the air, pressurized air from here to the engine. So we are supplying the engine with a densified air. Then we have the engine nomenclature: top dead center, bottom dead center, bore, stroke, strut volume, clearance volume, compression ratio, etc. So we have discussed all this particular nomenclature. Okay, we know what is the significance of all these particular things. Then we have the classification of the engines. We have the cycle on the classification on the basis of cycle. We have 2-stroke and 4-stroke. On the basis of thermodynamic cycle, we have the Otto cycle, diesel cycle, dual cycle. Then on the basis of method of ignition, we have SI engine and CI engine. On the basis of number of cylinders, we have single cylinder, multi-cylinder engine. We are on the basis of cooling system used, we have air cooled, water cooled, oil cooled, etc. On the basis of fuel used, we have petrol, diesel, gas, we have high speed, low speed, medium speed engines. On the basis of application, we have the automotive engines, aircraft engine, marine engines, generator sets, etc. On the basis of arrangement, we have vertical arrangement, horizontal arrangement, V arrangement, radial arrangement, opposed cylinder arrangement, opposed piston arrangement. So all these things we have discussed. Coming to the petrol engine, it was invented by this particular scientist shown in the slide, whose name was Nicholas August Otto, in 1876. So remember the year 1876, very important year from the engine IC engine point of view. So this was the person who invented the diesel engine, that is CI engine. It is Rudolf Diesel. So we have learned the petrol engine and diesel engine also. So when we compare a petrol and diesel engine, yeah, anybody having any problem? I hope no. Hello? Anybody having any problem? Any problem, anybody? I hope no. Okay. If you are having any problem, please unmute and tell me, please. Okay. So the petrol engine and diesel engine comparison is shown on the slide. Generally, petrol engines use Otto cycle, diesel engines use diesel cycle. We know. Petrol engines generally inhale air fuel mixture. Diesel engines inhale air only. Then we require a spark in petrol engine. We don't require a spark plug in a diesel engine. The compression ratio used is 6:12 in case of petrol engine. The compression ratio used is 14:22 in case of diesel engines. Petrol engines are generally having low thermal efficiency. Diesel engines are having higher thermal efficiency. Petrol engines are generally light in construction. Diesel engines are heavier comparatively. From the cost point of view, petrol engines are cheaper. Diesel engines are costlier. Vibrations are less in case of petrol engine because the combustion is smoother and the noise is also lesser. On the contrary, in diesel engine, the vibration and the sound is more in case of diesel engines. Uh, Petrol engines are preferred for agricultural applications, motorcycles, cars, or light duty vehicles. Generally, diesel engines are preferred for heavy applications like truck, buses, generator sets, and so on, marine applications, etc. So that was about the comparison of petrol and diesel engine. Now we have a comparison of two-stroke and four-stroke engine. Uh, Two-stroke, we have only two strokes. What is a stroke? The movement from one dead center to another dead center is a stroke. So only two strokes required to complete the cycle in case of a two-stroke engine. That is one revolution required. Um, in case of four-stroke engine, we require four strokes to complete the cycle or two revolutions. Uh, we get one power stroke per revolution in case of two-stroke engine, and we get one power stroke per two revolutions in case of four-stroke engine. We use ports in case of two-stroke engine. We use valves in case of four-stroke engines. Two-stroke engines are generally simple, light in weight, and low cost. On the contrary, four-stroke engines are complicated, heavy, costly. Uh, Theoretically, more power is generated by a two-stroke engine than a four-stroke engine. Piston shape is generally having a crown to deflect the mixture coming in case of two-stroke engines, but that is not the case in case of a four-stroke engine. Thermal efficiency is generally considered to be less in case of a two-stroke engine, but it is considered to be more in case of CR engines. Two-stroke engines are generally used for mopeds or scooters, or in some agricultural small applications, etc. Four-stroke engines are used in cars, bikes, etc. Nowadays, two-stroke engines are not there in the market. They are obsolete for automobile point of view, because it has a lot of disadvantages. And nowadays, we have four-stroke engines being used for almost all automobiles. Again, some more comparison between two-stroke and four-stroke. The less moving parts in case of a two-stroke engine, while more moving parts in case of a four-stroke engine. Less maintenance required in two-stroke engine, more maintenance required in four-stroke engines. Less expensive, or two-stroke is less expensive when compared to the four-stroke engine. Pollution is more generally unburned hydrocarbon pollution is more in two-stroke engine, but other pollutions are comparatively less when compared to four-stroke engine. We have a shorter engine life for a two-stroke engine when compared to that of a longer life of a four-stroke engine. Design of a two-stroke engine is simpler because we don't have the valves, etc. in case of a two-stroke engine when compared to that of a four-stroke engine. So that was about the two-stroke and four-stroke. Now moving to the last point, that is the timing diagram. Wall timing diagram is a graphical representation of exact moments in the sequence of operation at which two walls are open or closed. So obviously, when the walls or ports are going to open or close is being indicated on a diagram. Okay, so such a graphical representation is what you call as a timing diagram. In case of a four-stroke engine, we call it as a wall timing diagram, because we know that walls are being used in a four-stroke engine, and in case of a two-stroke engine, we are using ports, so there we call it as a port timing diagram. And the angular, since it is graphical representation in a manner where the crankshaft is being rotated, what is happening? We express in terms of angular position of the crankshaft. So in terms of degrees. So this is how a timing diagram look like in case of a petrol engine. Okay, so some degrees before BDC, what is happening? Some degrees after BDC, what is happening? Some degrees before TDC, what is happening? Some degrees after TDC, what is happening? In that manner, we go on explaining. This is a wall timing diagram for a two-stroke engine regarding what is happening when the walls are going to close, when the walls are going to open. Okay, what is happening when the walls are remaining closed? What is happening when the walls are closed, etc. These things we will be putting it on the graphical manner. Uh, so this is a two-stroke diesel engine. For a diesel engine, earlier what we have shown was about for a petrol engine. Here it is for a diesel engine. So the angles are going to change, and again it is a two-stroke engine. So we have uh, the ports being opening and closed. So two-stroke diesel engine, four-stroke diesel engine. Uh, so when the walls are going to open, when the walls are going to close, what happens if the walls are going closed early or late? What is going to happen? So these things we have discussed. Then we know that when you take any wall timing diagram, so if you take this wall timing diagram of a four-stroke engine, this is the point at which the exhaust wall is closing. Okay, and before that, here the inlet wall has been opened. So from here, that is from this point to this point, you can see both the walls are already opening, so remain open. So since both are opening, that is inlet wall is also remaining open and exhaust wall is also remaining open, whatever is coming through the inlet may go out through the exhaust also. So that is what you mean by wall overlap. So the overlap is a very important issue in case of four-stroke engines, and we have to ensure that the wall overlap has to be minimized as far as possible. So we have something called as a RAM effect to increase the volumetric efficiency, which we have discussed in uh, supercharging. Then so that was about the wall. So that was about some parts of constructional details of chapter number 1. Moving ahead, we have so two-stroke engines are generally of simplified construction. Uh, Power to weight ratio is higher. So this is how it is going to operate. So you can see how the two-stroke engine is operating. So you can see over here, there is a wall being opened and closed. The air is sucked in, or the mixture is sucked in, and that goes through the transfer port, and it will be transferred to the combustion chamber, and it will be burning and then going to the exhaust. So here we have the transfer port, here we have the exhaust port. So, and here we have the inlet. So the inlet is on the some side. So this is the working of a two-stroke engine. So how it is working is shown over here. So we have discussed all these things. Why two-stroke engine? Because the mass is low, less parts, moving parts are less. Specific power is generally, that is power to weight ratio is generally high. That means with the lesser mass of the engine, we can produce more power. Efficiency is less. Oil consumption is more. The unburned hydrocarbon emissions are less. More. Low compression ratios are generally used. RPM of such engines are generally high, and it can be used for generally off-road vehicles. Some motorcycles and mopeds also used. Lawn mowers, outboard engines, generator sets, such applications we prefer to use two-stroke engine. So this was about the two-stroke engine. So these are the different scavenging processes, how the gases flow inside a engine, two-stroke engine. Okay, so the smaller, one of the smallest two-stroke engine is shown over here. You can see it's a very small size. uh, engine. So different cycles and all we have explained. Okay, we have already discussed this, I think, the working of a two-stroke engine. So this is a four-stroke engine on the left side, and on the right side you have a two-stroke engine. Operation of a two-stroke engine. This so what happens when the piston moves from TDC to BDC? First the combustion happens, then the exhaust happens, then the suction happens, and finally the piston reaches BDC. Then the piston is moving from BDC to TDC. So presently the piston being at BDC, it is moving up. So as it moves up, you can see it is going to close the transfer port. Then it will also, at that time the suction ends. It will close the exhaust port also, and now the compression is going to happen when the piston reaches TDC, and the combustion is going to happen. So here you have the how it operates. So we have discussed. This is a port timing diagram. This is a theoretical one. Here the inlet valve opens. Here the inlet valve closes. When it moves, we have the compression at the end of when the piston reaches TDC. The ignition is going to happen. The expansion is going to happen. Exhaust is going to happen. Oh, sorry, I think this is a four-stroke diagram I have put. Okay, doesn't matter. It was just to indicate how the timing diagram is there. So coming to the nomenclature, we have here the stroke length, swept volume, clearance volume. Then the compression ratio is initial volume, total volume divided by clearance volume. That is this total volume divided by clearance volume. This is your compression ratio. Here we have the top dead center. Here we have the top dead center and bottom dead centers. Okay. So D is the diameter of the piston and the area. So all these things. This is a PV diagram for a four-stroke spark ignition engine, where we have discussed in detail what is happening during a in a auto cycle. Okay, so 0 to 1 is your suction, then 1 to 2 is your isentropic compression, 2 to 3 is your constant volume heat addition process, and 3 to 4 is isentropic expansion process. 4 to 1 is a imaginary heat rejection process, constant volume heat rejection process, and 1 to 0 is your exhaust. So starting from 0, coming back to 0, we have 0, 1, 2, 3, 4, 1, 0. Okay, and simultaneously the piston is going to move from TDC to BDC. Okay, so these things we have discussed in detail. So here we have discussed what is the difference between a Otto cycle and a diesel cycle. In a diesel cycle, we have 0 to 1 as it is, where now the up to 1 to 2 also is the same, but 2 onwards, here instead of a constant volume, here it is a constant pressure. Okay, so since it is a constant volume, it was going vertically. Since it is a constant pressure, so the pressure is remaining same over here, the volume is remaining same over here. So on this side we have a volume, on this side we have a pressure. So pressure remains constant here, volume remains constant here. When the pressure remains constant, we call it as a diesel. When volume remains constant, we call it as the Otto cycle. So 2 to 3 is a constant volume
Second one.
addition. 3 to 4 is adiabatic expansion process. And this is a constant volume heat rejection process. 4 to 1 and 1 to 0 is a exhaust process. So this is a comparison of Otto cycle and diesel cycle. This is a theoretical wall timing diagram for a four-stroke engine. So the inlet valve opens, inlet valve closes. We have ignition. We have uh, exhaust valve opening and exhaust valve closing happening in a four strokes. Okay, so uh, that is shown in this particular slide. Then whatever shown in this slide was the theoretical one. That is why it is shown at the dead centers. But we know that the walls are not going to open and close at dead center. Either they will be opened early or closed early or late, or closed early or late. And that is exactly what is happening here. So instead of opening at top dead center, it is opening, inlet wall is opening earlier. And instead of inlet wall closing at a bottom dead center, it is closing late. Okay, ignition happening instead of a top dead center, before top dead center it is happening. And exhaust wall, instead of opening at BDC, it is opening at before the BDC. And then exhaust wall closing instead of at top dead center, it is happening after TDC. So this is some degrees and all, everything has been shown. So this becomes the actual wall timing diagram for the four-stroke engine. We have the engine cycles, three types: air standard cycle, fuel air cycle, and actual cycle. Air standard cycle is the cycle in which we are working medium is air. Now we have assumed that this as a air standard cycle, so that the gas loss can be applied and we can solve the equation, so that we can have a rough idea regarding what will be the output of the engine. Okay, so for simplification process, we have used this air. Uh, in order to get the idealized values of the output, etc. But in actual, we have the air fuel cycle. So when we instead of air, we put the air fuel properties of the give the air fuel properties to the mixture, then or the working fluid, then we call it as a fuel air cycle or theoretical fuel cycle. And we have the actual cycle, which is again different. So some losses are there in, we are not considered in air fuel cycle because it is a theoretical. But in when we come to actual practical, we have some losses, and when we consider this particular losses, we get the actual cycle. And in this slide, we have discussed about the different losses. So you can see some losses over here. So 1 to 2, which was go like this, instead it is going like 1A. And from A, the spark was supposed to be theoretically given at 0.2, but the spark we are giving at A. So when spark is given at A, since the combustion starts, instead of this line moving like this, it will go like this. Okay, and as we move further, instead of moving like this, since the combustion is not instantaneous, it is taking time. But by the time the piston is started moving down from TDC, that is from here, it is moving towards right side, and therefore the pressure drops. So correspondingly, the curve go to BC. Instead of B3, it will go like BC. So ABC will be the curve going, and then expansion actually when it starts, it is going like this. And here the exhaust valve opens. So instead of going like D4, it will go like D1. So this is your actual cycle. So 1, A, B, C, D, 1. So that is your actual cycle. And theoretical cycle is 1, 2, 3, 4, 1. So that becomes the difference. And whatever the losses we have, it is a time loss. So here, whatever the losses was happening, we call it as the time losses. This losses, whatever is there, we call it as the heat losses. And we have this particular losses, whatever is shown over here, we call it as exhaust blowdown losses. So the different losses are shown here. In this particular Uh, so so that was about the different losses. So I think we have covered the chapter number one. So uh, once again, we will see the introduction we discussed, the constructional details we discussed, the classification we discussed, the auto cycle, diesel cycle, wall timing diagram we discussed, the port timing. Okay, I think port timing is remaining. Just check out. So we have a two-stroke engine. Okay, sure. Okay. Here we have the comparison. Then so this is a operation of a two-stroke engine. Piston is moving down, combustion is happening, exhaust is happening, then suction is happening that reaches BDC. This point we have discussed. Then the piston is moving down from BDC to moving from BDC to TDC. That is, it is moving up, starts moving up. Then the suction ends. Then the exhaust also ends and reaches BDC. Uh, Whatever happens is the cycle complete cycle, and this happens in one revolution. So only one circle. We are showing everything. Uh, so here inlet wall opens. So the inlet wall opens some degrees before TDC. From here we are starting explanation. Inlet wall closes here. Okay, the exhaust port opens here. Then we have the exhaust wall closes or exhaust port closes. So here it is exhaust port closes. Then the transfer port opens and the transfer port closes. Uh, Moving from TDC to BDC, what is happening? Initially, the ignition is given at the end of the compression stroke. The spark is glowing and the combustion starts. With the combustion, then the expansion starts. As the piston is moving, is pushed down. When it's pushed down, uh, it opens the exhaust port. When the exhaust port opens, the gases starts moving out. Then the transfer port also opens. The mixture, fresh mixture starts moving in. So simultaneously, both the ports are open, and the piston is moving down. So the continuously both the exhaust and transfer ports are remaining open, and the things both the things are going on. That is in suction and exhaust. Both the things are going on simultaneously. When the piston is moving up from BDC to TDC, piston is at BDC. Then it moves up and closes the transfer port first. So transfer port closes. Then the exhaust port also closes, and then it reaches TDC, and before that the ignition has to happen. So this is the port timing diagram for two-stroke engine. So I think we have gone for the discussion of our first chapter, covering all the points of the chapter number one. So if any doubt in this particular chapter, uh, you were unable to understand, and you feel you want some clarification on that, you may ask. So open for now doubt clearing discussions. Any doubt in chapter number one? You can ask me any doubt which you have in the chapter number one. We have revised it again today. Earlier we have discussed everything in detail. Today we have revised it. So any doubt in the chapter number one, please ask. No doubts? Anybody have any doubt in the chapter number 2? What we have discussed now? कुणाला काय डाऊट असेल तर विचारा. कुठल्याही पॉइंट बद्दल, कन्स्ट्रक्शन डिटेल्स, टायमिंग डायग्राम, मोटरसायकल, डिझेल सायकल, पेट्रोल इंजिन, डिझेल इंजिन, 2 स्ट्रोक इंजिन, 4 स्ट्रोक इंजिन, जी कुठले पॉइंट्स आपण डिस्कस केले या चॅप्टर मध्ये त्याच्याबद्दल कोणाला काही डाऊट असेल तर विचारा. Nobody having doubts with respect to first chapter? Okay, those who are having no doubts and who have understood completely the chapter number 1 may mark their attendance and leave the lecture. In the next lecture we will discuss chapter number 2. कुणाला काही डाऊट असेल तर विचारा. रिव्हिजन असल्यामुळे आपण फास्ट घेतलंय, कारण ऑलरेडी आपण या चॅप्टरला जवळजवळ 25 ते 30 लेक्चर दिलेले आहेत ऑलरेडी. Anybody having any doubt, please ask.
हॅलो
हा बोला
सर. 2 स्ट्रोक मध्ये पेट्रोल डिझेल वेगवेगळं असतंय ना इंजिन?
2 स्ट्रोक मध्ये
पेट्रोल डिझेल इंजिन मध्ये
2 स्ट्रोक पेट्रोल आणि 2 स्ट्रोक डिझेल हे वेगळं असतं इंजिन. 2 स्ट्रोक पेट्रोल म्हणजे आपण स्कूटर मध्ये वगैरे वापरतो ते इंजिन असते. 2 स्ट्रोक डिझेल इंजिन्स जनरली मरीन ऍप्लिकेशन साठी वगैरे वापरतात. पण 2 स्ट्रोक पेट्रोल आणि डिझेल दोन्ही मध्ये शक्य आहे. 2 स्ट्रोक पेट्रोल असेल तर आपण त्यात कार्बोरेटर वापरून मिक्सर तयार करून आतमध्ये देतो. डिझेल असेल तर फक्त त्यात एअर देतो आणि त्याच्यानंतर ऍट द एंड ऑफ द कॉम्प्रेशन स्ट्रोक वी गो फॉर इंजेक्शन ऑफ द डिझेल. पण 2 स्ट्रोक ऑपरेशन 2 स्ट्रोकच असतं, म्हणजे एका स्ट्रोक मध्ये सगळं होतं. पण दोन्हीकडे दोन्ही शक्य आहे, म्हणजे पेट्रोल मध्ये पण शक्य आहे 2 स्ट्रोक आणि डिझेल मध्ये पण शक्य आहे 2 स्ट्रोक. मरीन मध्ये भरपूर प्रमाणात 2 स्ट्रोक इंजिन्स असतात. 2 स्ट्रोक इंजिन्स जनरली त्याचा ॲडव्हान्टेज काय आहे की त्याची सिम्प्लिसिटी, जास्त कॉम्प्लिकेटेड नसतं, काय नसतं त्यात. फक्त एक सिलेंडर आपण ज्याला म्हणतो, म्हणजे सिलेंडर म्हणजे काय, फक्त एक होल असतं आणि त्याच्या आतमध्ये पिस्टन बसवलेलं असतं. मग त्याला काय वॉल नाही, वॉल टायमिंग नाही, असले काही कॉम्प्लिकेशन नाही. त्यामुळं मेंटेनन्सला खूप सोपं राहतं ते 2 स्ट्रोक इंजिन. म्हणजे ज्या ठिकाणी आपल्याला मेंटेनन्स पर्सनल अवेलेबल होत नाहीये किंवा मेंटेनन्स करणं आपल्याला अवघड जातं, अशा ठिकाणी आपण काय करतो की 2 स्ट्रोक जनरली प्रिफर करतो. उदाहरणार्थ आपल्याला आता शिपमध्ये वापरायचं आहे, तर शिपमध्ये काय आहे की इंजिन बिघडल्यानंतर आपण काही माणसं ह्याच्यावरनं मागवणार नाही. समुद्रात कुठेतरी जहाज आहे आणि इंजिनला थोडंफार काहीतरी झालंय तर त्याची मेंटेनन्स करायला आपल्याला माणसं काय आपण बाहेरून मागवणार नाही. मग आपल्याला काय की ती इझिली मेंटेन झालं पाहिजे. अशा ठिकाणी अशी जी ऍप्लिकेशन्स असतात जिथं आपल्याला मेंटेनन्स करणं अवघड जातं, अशा ठिकाणी आपण प्रिफर करतो 2 स्ट्रोक इंजिन्स, कारण ते सिम्पल कन्स्ट्रक्शन असतं आणि कन्स्ट्रक्शन सिम्पल असल्यामुळे मेंटेनन्स पण खूप सोपं असतं. आय थिंक आय हॅव आन्सर्ड युअर क्वेश्चन. ह्याच्या व्यतिरिक्त काय क्वेश्चन असेल तरी विचारा, किंवा समजलं नसेल तरी सांगा. तुमचं क्वेश्चन हेच होतं ना?
येस सर, येस.
हा, तर दोन्हीकडे शक्य आहे आपल्याला. पेट्रोल मध्ये पण 2 स्ट्रोक शक्य आहे आणि डिझेल मध्ये पण 2 स्ट्रोक शक्य आहे, काय अडचण नाही. फक्त
मला डिझेल
बोला.
डिझेल चेक केलं
हा
जातं का
बोला.
गॅस चेक केलं जातं? असं विचारायचं.
डिझेल नाही नाही देणार ठेवा. पेट्रोल ज्या वेळेला म्हणतो त्यावेळेला दॅट इज अ SI ऑपरेशन. SI ऑपरेशन मध्ये मिक्सचरच आपल्याला सक करणार. आणि CI डिझेल म्हणतो त्यावेळेला ती CI इंजिन ऑपरेशन असते. आणि CI म्हणतो त्यावेळेला ओनली एअर वी आर गोइंग टू सक. तिथं मिक्सरचा काही संबंध येत नाही, कारण आपण नंतरच परत इंजेक्ट करणार आहे. कारण डिझेल नंतरच आपण आतमध्ये इंजेक्ट करतो, अगोदर करत नाही.
येस सर, अंडरस्टँड.
मग तिथं कार्बोरेटर वगैरे काही नाहीये, फक्त एअर सक करणार. आणि ऍट द एंड ऑफ द कॉम्प्रेशन स्ट्रोक विल गो फॉर इंजेक्शन ऑफ द फ्युअल अँड द फ्युअल विल बर्न. Any other doubt? Any other doubt? Prathamesh Patil, PC, Sarade. I hope no doubt remaining. So we'll conclude our lecture here.